Hello. Today we're going to be looking at angles in a semicircle. Okay, so when we have a chord going through the centre of the circle, remember that's going to be called the diameter. The diameter splits the circle into two halves. So we have the top half here, and then the other half. When we then draw a line, which is going to be a chord, from one end of the diameter to any point on the circumference, it could be over here, it could be there, it doesn't matter, and then another chord from the other end of the diameter to meet at the same point. As long as these two chords move or go from either end of the diameter to the circumference, then this will be a right angle here. They will meet at 90 degrees. And that becomes really useful when we're trying to work out angles in a semicircle, because now that that's a right angle, and we know that all of the angles add up to 180 degrees, it then makes it quite easy for us to work out other angles. It also means that Pythagoras' theorem can apply if we're trying to work out distances, because that applies to all right-angled triangles. Okay. In practice, you can get questions that look a bit like this. So if we just ignore this one at the bottom just now, we'll just deal with the top triangle first. The questions will often ask us to work out all of the angles, or sometimes a specific angle. In this case, we're just going to work them all out. So we have a diameter because it's going starting at the circumference, going through the centre point to the circumference. They both meet at the same point, which means this is 90 degrees. So a triangle, angles all add up to 180 degrees. If we've used 90 here and another 45 here, that means we only have 45 degrees left to use here. So this one must also be 45 degrees. Okay, and then the one at the bottom, again, we have the same diameter, and we have a chord meeting the circumference, and a chord meeting the circumference. So this is also 90 degrees. 90 we've used here, we've used the other 30 here, that gives us 120 degrees that we've used up so far. We're allowed 180 degrees in a circle, in a triangle, which leaves us with 60 degrees here. Sometimes you'll get questions that look a bit more confusing like this. So it looks like there's a lot going on here, but in reality, there's two separate triangles. The red one, and then the one with the blue top. Okay, so to work out all of the missing angles, we don't have enough information about the red triangle yet to work anything out, except that we know that this is going to be 90 degrees, and we know that this one over here is going to be 90 degrees. So in the blue one, we now know that we've used 90, we've used another 70, so that's 160 total degrees we've used so far, which means that this here must be the difference between the 180 and the 160, so that is 20 degrees. Now we can add this 20 and 40 together to know that this entire angle here, from the red one, all the way around, is 60 degrees. We have 90 and 60 gives us 150 degrees. The difference between 150 and 180 is 30 degrees. So this smaller angle, this part here, is 30 degrees. Okay. Final example. Sometimes the lines won't stop at the circumference, so it's not as immediately obvious what's happening. You just have to have a look at the picture and notice that we still have the same situation. We still have a diameter going through the centre point to the circumference. We have a chord meeting the circumference, and we have another chord meeting the circumference. So this part here is still 90 degrees. Then we can use our knowledge of vertically opposite angles. So tell us this one's 90 degrees, and this one is then going to be 90 degrees, and this is 90 degrees because of supplementary angles. Now, inside the triangle, we've been told that this angle here on the outside is 120 degrees, which leaves us with 60 degrees in here. Now again, 90 plus 60 gives us 150 degrees, so we must have 30 degrees left over here. That didn't really work very well. I will rub that out. $30 degrees. Okay, that should give you enough information to be able to do all of the exercises in today's work. Thank you.